So in this section, I'm going to talk a little bit more about VAT, Vertex Animated Textures. And what I want to show in this one is we take the initial VAT GD shader that I created, and we're now going to push it a little further, where now we can actually do multiple indexes on that animation and basically get different animation states. It doesn't create, huge textures. The data doesn't multiply by a lot. I will show you how it works, and I'll also back up and show you how I moved to this zombie model. I think I talked a little bit about it before, but we're gonna go back to that. So the zombie model, this was something I created in early 2024 actually, and when I created the idea to make this a zombie city builder, I was like, okay, I have to use this model. And so I did a bunch of work on reducing the poly count quite a bit. So it's possible I could reduce this further. But this, I was able to reduce the poly count to about 1,300 triangles and maintain most of the fidelity of the model. So I'm reasonably happy with that. And then the good part is too, is if you subdivide an edge, kind of like this, using Control X, a couple things happen. One is you retain the UV shape. So you'll notice the UV mapping doesn't really get very screwed up when you do that. The other thing that happens, and I should undo that, is that your bone deformations are all still good. So the weight paints that are applied to the vertices, they basically stay even after subdividing. So I did a lot of work on that to try to reduce the poly count. And the big reason you want to reduce the poly count is in Vertex Animated Textures, you kind of have to remember that your positions, this number of columns here, is exactly equal to however many, vertices there are. So if you have, I think this model, triangle count, sorry, it's not the right metric to actually look at. We should be looking at the vertex count. So if I have 723 vertices, that means there's going to be 723 columns. And I'm actually going to pull up this texture. I'm going to pull up the completed texture and I'll show you how I built it. So if we go to, I actually can't remember where I put this, maybe assets, model, zombie. Yeah, it's in here. So let's take a look at the positions.exr and open this in GIMP. So while that is opening in the background, there's one key thing that makes this work. Of course, we have the VAT plugin, which I'm not running just yet. I think I'd have to open it up here and hit play. So we get the VAT plugin, and this script is included in the downloaded package for this series. And you're going to process the anim meshes, and a couple things to note is that this only processes the animation that's currently active. So if walking is active, then that's the one that's going to be processed. Now, the tricky thing with this rig, there's actually a bit of a bug with this rig, and I don't know why it's happening. But in order to change this to the other animation, if we want to go to idle, we'll call this actual idle, I have to set it on both the mesh and the rig. So like I said, I don't quite understand why that is the case right now, but that's why the two animations are different. Now, one has 151 frames, and one has only, I think, 70 frames or 71 frames. And actually, I think I got those numbers backwards. This one starts at 1 and ends at 151, so this is exactly 150 frames. And the other one is 75 frames. Walking goes from 1 to 76, which is 75 frames. Now, the trick for making this work with two animation poses is very difficult. What you need to do is you need to make the first pose of the idle match the first pose of the walking. All of the animations, when you bake out animations using this pipeline, all of the animations are actually relative to the first key pose. And I can actually show you that right here in the add-on. The meshes, the way this is indexed, the way this variable gets passed into get vertex data, this array is actually the array of the collection of mesh objects for each one of the keyframes. So 0 is the first keyframe. So the thing to keep in mind is when you do VAT exporting, all of the vertex positions for each point in the animation is relative to that position. So how do we actually make this work? What you're going to do is you're going to hit that export button twice. You're going to attach the idle animation to your rig, right? And then you're going to click on the mesh and export. And then you can go through the same process we looked at in the last video. When you do that, you're going to get an image that looks like this. And so in this case, this image was 723 wide, right? So that's 723 vertices, just like we saw here, 723. And it's 150 pixels high, so half of this. It's this many high. Now, that is the number of keyframes. So there's exactly 150 keyframes in the idle animation. So if we go to idle and we switch back to here, we can see here's 150 keyframes. So really the trick is making sure the first keyframe of both the idle and the walking match. Sometimes it's a little tricky to make that happen, but you can make it work. And then all you do is you stack your image textures. The idle is actually going to be on the bottom, which I want to be index 0, and walking is on the top, index 1. And it's not a big deal if you mix them up, as long as your positions and normals are straight for both of them. So for me, it actually ended up that walking was index 0 and idle was index 1. So let's talk about this and how that actually the shader works on Godot. So I've got a couple things going on here. I'm going to skip past this first section because this is a little complication that actually comes from the multi-mesh instance aspect of this. All this part of the shader is the same, but we do have a new parameter here for the number of anims that we have. So in this case, I have 2 animations, idle and walking, so we set this to 2. And then the animation index, which we can set to 0 or 1 very easily, and that changes the state. So what we do, this whole computation had to change a little bit. So you'll notice this is a little bit different from the VAT GD shader. But this basically supports, any n number of animations as long as you stack them up like this. So what we do is we get the time variable as normal. We're going to get the frame. Now, before I think we were converting this to not just a frame, but I think we were also dividing by the total number of frames. So this value here was actually a percentage of the frames. This is a bit different. This is literally the frame number. So we take the time, we multiply it by the FPS in order to get what frame we're currently at. And we do mod on the total frames. So in this case, our total frames is 150. So we can go from 0 to 149. And then once we get to 150, it wraps back to 0, right? So you're always getting this wrapping between 0 and 149. What I'm doing here is I'm pulling this directly from the uniform. So this anim index here goes right into this variable. I'll try to explain this top part in a minute. And then this part changes a little bit too. So let's just remind ourselves what UV2 is. If we look at the mesh and go to UV editing and click on UV, this is not the right mesh. We need to go to the export mesh. So let's hide the rig. Let's click on the export mesh, and then we see this vertex anim here. So remember what this is. This puts each one of the vertices, so there's 723 vertices, it's going to place on a unique location. That first vertex actually goes between 0 and 1, and it goes right at 0.5. Well, not 0.5. That's not the right. That's not the right term. It goes between how you divide the image into 723 columns, and then it goes into the middle of that column. So that's why it has this X position of that. And once again, the reason we create that UV map is that each one of the vertices of the mesh gives a unique mapping to the columns, right? So, and remember what the columns are. The columns are the vertices and the rows are the keyframes. So we want to pull a position for each one of the keyframes. So once we have UV2, we give the animation height. So that's 1 divided by the number of animations. So in our case, this is 2. So 1 over 2 is 0.5. And what we're trying to say is, for the whatever animation index we're at, we're only going to look at 0.5 of the UV space, right? So if it was the first animation, we're just going to look at the first 0.5 of that height. Because remember, UVs are going to squash this whole image into the 0,1, into a 0,1 space. And then we normalize the frame. So this is very similar to what we did here, where we take that modulus of the frame count and divide by the total frames, so it gives us a percentage. And then we get this slice start, which is the animation index times the animation height. So for instance, if we're at animation index 0, the slice start is 0. If we're at animation index 1, the slice start is 0.5 because it gets multiplied by this guy. And then the frame position is going to be 1.0 minus the frame normalization. So at 0%, this goes to 1, and then it gets multiplied by the animation height. and then at 1% it goes to 0. So we're actually starting at the bottom and working our way up. Sorry, I had that backwards. We actually start at the top of that section and work our way down, right? So if the index is 0, let's assume the index is 0 here. The frame norm is going to be, let's say, for instance, it's at 0%, and the animation height is 0.5, and then the frame position gets the slice start. So our slice start would be 0 for an animation index of 0, which we could change that here. And then, so this chunk of is basically 0, and then this one starts at 0.5 and comes down this direction towards 0. So that's the way the frames are, the rows are iterating. So that's why we set the Y there to be that that value. And of course, the X is what we sample. So the X gives us the vertex, but we can use the X and the Y to get a sample of the position and normals. Okay, so that's basically it. That's the magic of it, right? You break this up into chunks based on however many image segments you have, and then you scan down as the frames progress to sample the next part, right? A little bit of tricky part in GIMP, you have to make sure these images align perfectly. That just involves, resetting the canvas size. Originally this was 150, but I changed it to 300. And then I had to resize the layer to fit the canvas, which is, I have Shift I as a shortcut for that. And then finally you paste in the other position and normal image into this, and we save it all as an EXR. So as long as you save everything in EXR, all the default export settings are good from GIMP. You don't lose any precision or anything. And then it all works perfectly in here. The one thing I actually could not figure out, and I spent a long time doing this, is I couldn't get the normals to quite work out. So the normals are actually a little bit funky right now. And what these normals are, if you look at where the shadows are and where the light's hitting, these are just the normals from the original base pose. So if we look at this pose, this has certain normal values for those vertices. It's just using those all the time. And this is a reasonable approximation if you're not moving around too much. But if you have a mesh that's moving wildly, this approximation might not work. So there is something wrong with either my swizzling of the normals or how it's being passed to the fragment shader. I can show you. It just doesn't look right, basically. So the normal is not, the normal is not facing the right direction at all. The sun is up there, and we can see the shadows behind the character, but there's light on the back. And then the real thing that gives it away is that as you rotate the character, you're not seeing the correct shading, right? It kind of sort of looks right, but also it's like it's not quite right. Mainly because when the character is facing away from the sun, we don't get any light on. Only from certain viewing angles do we get light on the front. So I'm sure this is just a shader, like either view or world space issue, but I could not figure it out. And for me, it didn't affect the fidelity of the game too much just to use the normals from the original mesh. So now when we rotate this guy around, if I can click him, if we rotate him around, we see the lighting actually changes properly. Okay. Yeah, so that's one tiny thing I couldn't quite work out. But that's basically it. So this shader will also be included in the package. I'm calling this VAT multi because you can basically include however many animations you want. You just got to stack them up yourself. It would be cool to write a Python add-on that could do this, but it actually gets quite a bit more complicated because you have to switch animations, you have to do stacking of the image. It complicates it, in my opinion, more than what's necessary, considering that this base plugin gets you so close to having this work, basically. So what does this look like in game? I think I did show it last time, but we will spin this up and load a bunch of houses. I forgot about the title screen. So play and then nibble forward. Okay, sure. It's kind of fun. And basically we can just plop down a bunch of houses and we'll see how the animation responds. Let's do one at a different angle. Maybe that angle. All right, we'll go 8x, and then we'll put in some roads. And then maybe a couple of stores. If I can click it, there we go. So we see all of their animation states. It's cool. It's cool to see the different animation states. And remember, the reason... Oh, that's kind of broken. I'll show you why. I'll show you why this is broken. I forgot to reset something. We'll do that again quickly. So what I was doing here, and I said I was going to talk about this top part, and I didn't. This here is just for testing. TBD, to be deleted. This uses a uniform, but really what I want to do is I want the animation index to come from instance custom data. And you guys have seen that. I will show you in the code where it happens. But basically, we set the animation state. I think it's in here somewhere. I got to find it. But we're going to set instance custom data. And I think it's, yeah, I think it's right here. So for the instance that we're dealing with, we're going to set the color data. Okay, so the color is always, we're going to get that instance custom data first. The color is always instance custom data, instant custom O, I think is what it's called, or what's it called? Let's see. Just instance custom is a color with 4 channels, and that's RGBA. So we're going to grab the instance custom data for this particular zombie, and then we set the value to 0.1 or 0.3. And what we're doing in here is we're just saying if the index is less than 0.2, so let's say we set it to 0.1, that's equivalent to the idle animation. And then if it's between 0.2 and 0.4, we're going to say that's equivalent to the walking animation, right? So let's try that again. I just quickly set up this little town while the video was paused there. And now we should see animation states that are correct. So we got the little zombie guys. They go idle when they're just hanging out in the yard. And then once they start walking, they move. So very cool to see all this come together. Let's bump along the simulation and get some of these people going to work. They should go to work on Monday. There we go. And I wanted to do a little test here just to see how the pathfinding works. So for instance, I'm curious like where people from this house, what path they take. I think it's probably better for them to go around this way, and all we're looking at is the results of the A-star algorithm, that's all. Oh, these 3 guys go home this way, and then everybody else goes the other way. So, I don't know, it's kind of cool. It's kind of cool to see that in action. But yeah, that's how you can do different animation states. I still haven't linked the animation speed yet. That should be a fairly simple one. I'm procrastinating on it for some reason. But the animation speed, oh, I guess I don't have a parameter for animation speed yet. I think what we need to do is multiply the FPS by the animation speed. So we're actually going to divide it by the speed. So at 1.0, it's 30 frames a second, but at a speed of say 2x, this would be divided by 2. It would be 15 frames a second. So yeah, that's going to be the next thing I do. But yeah, it's honestly very cool. I was very happy to see like this multi-mesh level optimization with VATs. They all have the same texture. They all have the same mesh. And yeah, you get some pretty cool emergent behavior. So this segment was really short. That's all I really wanted to show. I'm really excited to see what people could do with this VAT thing. I know I've been hearing about VAT for over a year, so it's just taken me a while to figure out how to do it in Godot. But awesome to see it work so well and that it's so well optimized.